For the introduction, many application problems in calculus involve functions which you want to find the maximum or minimum values. The restrictions started or implied for such functions will determine the domain from which you must work. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value. As example, the extreme value theorem, the first derivative test, or the second derivative test.
The objective of applying maximum and minimum problems is first to identify the quantity to be maximized or minimized. Second, the objective is to apply the knowledge about the derivative and critical points in solving the maximum and minimum problems. Lastly, to solve the maximum and minimum problems easily and accuracy.
Guys, let's take a look at the question. A rectangular storage area is to be constructed along the side of the tall building. A security fence is required along the remaining three sides of the area. What is the maximum area that can be enclosed with 800 meters of fencing?
Okay, basically to solving these problems, we must draw and express our imaginary. So this is the diagram for this question. So we list out all information that we get from the questions like this. So the perimeter is 800 meter, which is the security fence that connected to the building. So we assume this is X, the length, the width is Y. So we get 2x plus y as the perimeter. We can calculate this because this is the part of the building. As we assume the perimeter is 2x plus y and also the perimeter is 800 meter, so we can build up an equation such as 2x plus y equal to 800. So y equal to 800 minus 2x. The second part is, from the diagram, we also know that the area of the security fence is x multiplied by y. So the area is x multiplied by y. We get the y equation is equal to 800 minus 2x. And we substitute y in the equation of area, which is equation of area is x, y. So when we multiply it, so x multiplied by bracket 800 minus 2x. So we get the final 800x minus 2x squared. So we differentiate the value of area like this. So we get 800 minus 4x. From that, to determine the maximum or minimum value of the earlier value, we get the negative 4 as the value of second derivative. So negative 4 is less than 0. So we conclude it as maximum value. After we determine the maximum or minimum value, in order to find the value of x, we must equal the first derivative equal to 0. Remember, the first equation that we get earlier is y equal to 800 minus 2x as the value of x that we find earlier. So we must substitute the value of x into the equation of y. So we get y equal to 800 minus 2 bracket 200. So we get y equal to 400. Hence, as the value of x and the value of y already found, so we can substitute it to the equation of area, which is area is equal to x multiplied by y. So we get 200 bracket 400. So we get 80,000 meters square.
Okay, so for the conclusion, we can conclude that the quantity to be maximized or minimized can be identified. The knowledge of derivative and critical points in solving maximum and minimum problems can be applied, and maximum and minimum problems with ease and accuracy can be solved.
Bye.